This is the second part of 2.6, all about step functions. The next video I'll make will have to do with absolute value functions. Okay, so step functions are just another type of piecewise function. So if you think about some of the examples we saw in the previous lesson, if we have just a bunch of horizontal segments like 1, 3, 5, 7, when x is between 0 and 1, we have a little horizontal segment right there. When x is between 1 and 3, we move up here to the horizontal line at y equals 3. And then if we just continue graphing these, we're going to notice this little pattern, and it almost looks like we're kind of like hopping up. Okay. Notice that on each vertical line there's an open circle and then a closed circle, an open circle and then a closed circle. Okay, and this is going to continue on potentially forever and ever and ever with step functions. Okay, so step functions are also called greatest integer functions. They're also called floor functions. Don't know why they're called floor functions, but that's how Desmos represents them. And they're represented by these little double brackets. So think about how like absolute value symbols have these little bars. The greatest integer function or the step function has these little double brackets. So I draw a regular bracket and then put a little line there. And that's how I draw that symbol. And so what this means, so like an absolute value symbol, it takes a negative number or a positive number and it answers the question of how far is this number from 0 on a number line. What the greatest integer function does, when you plug a number in, you see, or excuse me, it will tell you what is the greatest integer less than or equal to the number that you gave it. Okay, so with some numbers like these, think about a number line. Okay, so where is 1.8 on a number line? It is between 1 and 2. It's closer to 2, but it's not quite there. Okay, and so the definition of a step function, it's going to give us a number, or excuse me, the integer less than or equal to x. So it's not gonna quite reach 2, that 1.8 number. So the greatest integer function is gonna spit out 1 for us because it is the integer that 1.8 is closest to that's less than or equal to it. Okay, so with 8.0001, if we carry on our number line, 8.001 is just barely above 8. So because 8 is less than or equal to it, 8 is what the function would spit out for us. Okay. Thinking about 5.99999, it is almost to 6 on the number line, but not quite there. So the function is going to spit out 5 for us. With negative numbers, we have to be really careful because the intuition is kind of like opposite. So thinking about a number line, negative 7.78 is right here on a number line. So what integer is less than or equal to this number? It's the integer that's to the left of it on the number line. So this is actually going to spit out negative 8. Okay, and then with thinking about negative 2, negative 2.001 is right here, and so the integer that is less than or equal to it is actually negative 3. Okay, so when we're working with these graphs, it can get a little bit messy, but not so much so that we can't handle it. Okay. So I think the easiest way to work with these graphs is by thinking about them kind of like in ranges. So think about starting at 0. Anytime we start at 0, that's typically helpful with graphs. So anything up from 0 all the way up to 0.99999 repeating. The greatest integer function, thinking about our number line, for as long as we're in between these two values, it's going to jump back and spit out 0 for us. And then anything above that, so the next range, if we go to 1, as soon as we reach 1, all the way up to 1.99999 repeating, it's going to spit out 1 for us. Okay, and then 2, all the way up to 2.999, it's going to spit out 2. We could keep going in the positive direction, but let's go back to the negatives. So if we go the opposite way on the number line, from 0 down to negative 0.99999, so negative 0.999 repeating, it's going to spit out negative 1. And then from negative 1, for this range, negative 1.999 to negative 1, it's going to spit out negative 2. Okay, and so this little graph, it's going to be pretty cute. In that middle range from 0 to 0.99 repeating, we're going to have a closed circle at the origin and then an open circle here. Because at 1, as soon as we reach it, it jumps up to 1. And that should be an open circle right here. So closed circle, open circle, closed circle, open circle, closed circle, open circle. Okay. And then down here we'll have an open circle, closed circle, open circle, closed circle, and then it just keeps going. Okay, and it could go forever and ever in either direction. So the way to work with Desmos with step functions, you have to type in the word floor, open your parentheses, and then put X. And so this is what it looks like. Okay, notice it's not perfect. We can't see which circles are closed and open, but we are able to see, you know, what that looks like. And if we zoom out really, really far, eventually it just starts to look like a line. So that's kind of cool. We're not going to worry about these examples until we get into function transformations, which is the next section. So go ahead and skip over examples 3 and 4. And then we'll pick up the next video with absolute value functions.